Math 4s. This is the day before your test. Your test is on Wednesday, the 16th of September. I just wanted to make this quick video to kind of show you guys what's going to be on your test and to give you guys some examples of some problems that you might see on your test so that you will be prepared for your test, or what I would like to call it, an assessment for tomorrow. So, just like yesterday, we went over all of the standards that are going to be represented on your test, except for the standards that are about vectors. We are not going to be doing the vectors, these standards here, because I just felt like we did not go over them enough. However, on the test, or on the assessment, there are 2 bonus questions, all right, that have to do with vector subtraction and addition. So if you want to study those, you can, but just know that they're bonus questions. They're not going to be part of your test grade unless you get them correct. Okay, just a breakdown of the test by each standard here. You're going to have 7 questions within your test that are about complex number operations, and there's 1 performance task having to do with complex number operation. Matrix addition, subtraction, and scalar multiplication, there are 2 questions on the test and 1 performance task, which means probably total there's about 10 questions on those. And then matrix multiplication, there are 3 questions on the test. Powers of I, which we're going to talk about, there are 4 questions on your test. Simplifying, there are 2 questions about that on your test. And then composite functions, there are 5 questions on your test relating to composite functions. So I just want to kind of jump ahead here to these examples. In this first example, we are doing actually 2 things, and there's not going to be anything on your test that looks even a little bit like this. You're either just going to be adding or you're going to be multiplying. In this case here, I just wanted to give an example where both those things were happening. So when we're adding, we have to have the same order. So remember that the order is the rows by the columns. Okay. So in this case, we have, if we were to make this matrix A and this matrix B, all right, A has an order of 2 times 2, and B has an order of 2 by 2 as well, which means they're the same, so we can add them together. So I'm just going to kind of take this part in the parentheses here and just go ahead and add them together. So we've got A, which is 5, 3, negative 6, 2, adding to B, which is 1, 2, 2, and 0. Okay, and you're just going to add the same elements together. So if this is the 1/1 element, all right, because they're in the first row and first column of both, I'm going to add those 2 together to get the 1/1 element in my response, or my answer. So 5 plus 1 is 6. So in my answer, all right, 6 is going to be the 1/1 element. All right, when we talk about the 1/2 element, all right, I'm going to be adding 3 and 2, which gives me 5. So that will go here in my answer matrix. All right, and then we'll do the same with the 2/1 elements. Negative 6 plus 2 gives me negative 4. That will go here. And the same with our 2/2 elements. All right, 2 plus 0 gives me 2. All right. There's my answer matrix for just A plus B. All right. All right. Now we need to go back, and we're multiplying A plus B to C. We'll just label that matrix C. So for multiplication, we have to make sure that the number of rows in the first, in this case it being C, the first matrix, match the number of rows in our second matrix, or number of columns, in our second matrix. We have compatibility because we have 2 rows on this in our matrix over here, and then we have 2 columns in our matrix over here. So we know that, right? We know that we can multiply these two together. All right, multiplication is a little bit harder than addition, all right, because we are going to be multiplying the rows by the columns. So we're going to be multiplying this row by this column to get our 1/1 element. So what that looks like is 2 times 6 plus 6 times -4. All right, that gives me 12 plus a -8, or excuse me, a -24. Getting ahead of myself. Right, -24, which gives me -12. All right, so in my answer matrix, which I'm just going to kind of put down here, -12 is going to be my 1/1 element. To get my 1/2 element, I take my first row in my first matrix and multiply it by my second column. Almost exactly the same, just with different numbers, right? So 2 times 5 plus 6 times 2. And that's going to give me 10 plus 12, which is 22. That'll go right here in my answer matrix. All right, let's move on to our second row. Trying to choose a different color here. All right, of our answer matrix, which means we're on the second row of our first matrix, and we're going to multiply it to the first column in the second matrix. So I've got -6 times -6, or +6, +6, sorry about that, plus 4 times -4. Okay, and that'll give us a -36 plus a -16, which gives us -52. Oops, I knew it was going to do that. All right, a -52. All right, so that means right here we'll have our -52. And then our last one, let's do it in pink, second row times the second column. So I'm going to have -6 times 5 plus 4 times 2. So that gives us -30 plus 8, which gives us -22. All right, and this is actually going to be our correct answer. If you guys want to know where I got this problem from, it's on those extra worksheets that I gave you guys at the end of lesson on Monday. All right, quickly moving on to some complex number stuff. We're going to be just doing the multiplication. Remember, there will be some adding and subtracting, but remember when we add and subtract complex numbers, we add the like terms. So we add the real terms and we add the imaginary terms together. But I want to just do some multiplication because I know that we probably didn't get a whole lot of exposure to this. So 1 minus 7i squared, if you guys remember from Math 2, when I square something in parentheses, that means I am multiplying it to itself. Okay, so this is what that question looks like when I expand it. All right, and so it doesn't matter which method you use, whichever you prefer, that's what I want you to use. I'm going to use the box because most of you preferred the box. Okay, so I'm going to make a 2x2 box. Okay, 1 minus 7i on the top and 1 minus 7i on the bottom. Okay, and a lot of you guys in the Pear Deck were struggling just a little bit with this, so I definitely wanted to do one of these problems. 1 times 1 is 1. 1 times -7i is -7i. And then 1 times -7i is -7i. And then -7i times -70i is going to give me a positive 49i squared. So a lot of you got to this point on the Pear Deck, and you knew that you would combine these terms, but I'm just going to write out what we have. So it's 1 minus 7i minus 7i plus 49i squared. Okay, these two are going to combine because they are like terms, all right? So I will have 1 minus 14i plus 49i squared. We're going to talk about this more when we get to our power of I section on this short little tutorial thing. But I squared, remember, that's the square root of -1 squared, which is just -1. All right, so this is where a lot of you guys were getting stuck on the Pear Deck, okay? So this is actually going to be 1 minus 14I plus 49 times -1. All right, if we multiply that -1 to 49, we're going to get minus 49 or -49. So 1 minus 14I minus 49. And now that there's no I squared with it, we can actually combine -49 and 1 to get -48 minus 14I as our final answer. Following that example, I wanted to jump quickly down to this powers of I here on your paper and just talk about it. We talked about it like super briefly in class, so I wanted to kind of make sure that we hit it again before you took your assessment. Remember that I is equal to the square root of -1, and that I squared is equal to -1. All right, so when we have like powers of I that are to like these extreme powers, extremely highly powers, all right, we're going to kind of break it down so that it's a little bit easier. So there was a time where I told you guys to break it down into I squared. So that's what we would do, all right, but we don't want to do I to the 200th power and then write I squared times I squared times I squared 100 times, right? So we know, well, hopefully you don't want to do that. So we know that we can use kind of the power of 2 to kind of help us. So we're actually going to do 200 divided by 2, which gives me 100. That means I would have 100 I squareds being multiplied to each other to get I to the 200th power. So what that means is I would have 100 -1s being multiplied to each other to get I to the 200th power because I squared equals -1. Well, since 100 is even, right, remember a negative times a negative is positive, and 1 times itself is just going to equal 1. So if when we have our power, if it's even, it's going to be +1. Similarly, okay, with 30 here, if I have it, all right, I get 15, which means I'm going to have 15 I squareds or 15 -1s being multiplied to each other, all right, which means this is an odd number. So I'm going to have -1 times -1 times -1, and I'm going to be oscillating between positive and negative, but my final answer is going to be -1. Okay. When we get to like odd numbers like these two examples here, okay, 313, I always go to the, even number that's directly under it. All right, and I divide it by 2. So 312 divided by 2 is going to give me an even number here, which means I'm going to have 156 -1s being multiplied to each other, but I'm going to still be left with one I. So I'm going to have an I still in my answer. All right, I just need to know if it's positive or negative. Well, remember, we said evens will give us a +1, so we're just going to have +1I. And you can put that 1 in front of I, but you don't have to, because 1 times I is just going to give us I. And that's going to be kind of the same with 35 here. I'm going to find the nearest even number and divide it by 2, okay, or the even number that's directly under it. All right, and 34 divided by 2 gives me 17. I know I'm going to have an I left over because that will give us 35 I's, right? And then 17 is odd. And remember we said when the half was odd, we were going to have a -1 as our answer. So right here, I to the 35th power is going to give us -I. All right, let's move on to some composite functions. So remember, for composite functions, we are using the inside out method. All right, I think the concept of the method is very easy for you guys to understand. It's just I think we're having problems with computation and simplifying there at the end. So I have f of x equals x squared plus 3 and g of x equals 4x minus 3. And I want to find the new equation f of g of x. So I kind of rewrite this. Well, not really rewrite it. All right, f of g of x. Okay. I'm going to start on the inside. So g of x is on the inside. So I'm going to have f of 4x minus 3. All right, so this was the part where you just had to kind of input g of x. And then f of x is on the outside here, but I do need to include it. So here's how I include it. Where I see the x in my f of x equation, that's where g of x should remain. So I would have 4x minus 3 squared plus 3. So now now f of x is included in our equation here. Okay. All right, now I'm just going to simplify. This is technically a correct answer if you wanted to stick with that. However, most likely they're going to have you expand that 4x minus 3. So we got 4x minus 3 times 4x minus 3 plus 3. I'm going to use FOIL this time. All right, so first would be 4x times 4x, which gives me 16x squared. Our outer is going to be 4x times negative 3, which gives me negative 12x. Our inner, let's choose a different color. Our inner is going to be negative 3 times 4x, which is negative 12x. And then our last is going to be negative 3 times negative 3, which gives us a positive 9. And then don't forget to bring down this plus 3 as you're continuing to write your equation. All right, combine like terms, and then we should be finished. So negative 12x minus 12x, the 16x squared can't combine with anything, but I'm going to get negative 24x here, and then positive 9 plus 3 is going to give me plus 12 here. So this would be this would be f of g of x. All right, is my final answer there. So these types of questions where like that, the answer or the question is like that, all right, you should have an equation as your answer. All right, let's move on to the very last example I want you guys to have a look at before your assessment on Wednesday. All right, is just solving for a certain value and in a composite function. Then we're still going to be using the inside out method. Inside out. So when we get these types of questions where it's got the fog there, I like to rewrite that as f of g of x, only because it's easier for me to visualize the inside out method. And actually, we're not going to put x there, are we? We are going to put of negative 4. So inside out method, I'm going to start with the inside. So I need to find the g of negative 4. All right, g is n squared plus 5n. So where I see an n, I'm going to put a negative 4 instead. All right, and then just solve. So negative 4 squared is 16 minus 20, because 5 times negative 4 gives me a negative 20. And I actually, ironically, get negative 4 again. Okay. So now that I have g of negative 4, all right, I can plug that in to f. So it's the same, all right, but just remember that that's where I'm getting it from. So f of negative 4, I'm going to plug in negative 4 where I see an n in my f function. So I've got 4 times negative 4 plus 4. Okay. 4 times negative 4 is a negative 16 plus 4 gives me a negative 12. So my answer of f of g of negative 4 is negative 12. Again, you guys can find all of these questions on those worksheets that I sent out on the Pear Deck on Monday. I know this is a long video, but hopefully it is helpful in preparing for your assessment. So I hope you have a good evening and study, study, study.